Hello and welcome back to Mr. Frina's Geometry. Today we're going to discuss simplifying radicals. Second semester, this concept is very, very important, okay? Because what we don't want to do is we don't want to be rounding all the time because we can get, answers that are significantly off when we're calculating with rounded numbers. So simplifying radicals becomes very important. Now, the first thing you need to know, when we talk about a radical, what are we talking about? We're talking about the square root, all right? And when we take the square root, we say the number inside is the radicand. And when we take the square root of that, that ends up being the root. Now, by definition of the square root, we basically say if, a squared equals b, then the square root of b equals a. With letters, that doesn't make much sense. But if we take it and we change it up a little bit, using numbers, if 3 squared equals 9, then the square root of 9 is 3. So basically, what to the second power would give me the number inside. That's what the definition of a radical is. Okay? Something that's very important for simplifying radicals is knowing and understanding the list of perfect squares. If you don't have these memorized, there's an easy way to calculate them. We'll talk about that in a minute. But on top of that, you want to have them by your side when you're working, if you're working with them for the first time. So the list of perfect squares, if you take your counting numbers and square them, it gives you the list of perfect squares, such as 2 squared is 4. 4 is a perfect square. You have 9, 3 squared. And we have 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared 144. 13 squared is 169. And 14 squared is 196. So basically what I did is I took our counting numbers and raised them to the second power. Now these are all perfect squares because if you take the square root of them, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4. Okay, that's why we call them perfect squares. So let's talk about simplifying radicals. When we simplify a radical, what we're looking to do is use a property of radicals, such as when we multiply the square root of a times the square root of b, you can actually combine them as the square root of a times b. You could also do the opposite. If you have the square root of a, b, you can break it up into a product of two radicals, square root of a times the square root of b. When we do this, what we do is we look for a perfect square that goes into the radical, starting with, not square root of 16, let's go square root of 32. I look at the square root of 32, I want to break this up into a perfect square, alright, and the factor that it multiplies with to give me the radicand. So what is the largest perfect square from this list that goes into 32? I like to start from the top. Does 36? No. Does 25? No. Does 16? Yes. 16 goes into 32, so what we do is we break this up into the square root of 16 times. What times 16 gives me 32? 2. And now, when I look at this, this becomes the square root of 16 translates to 4 root 2. Now, if you plug both root 32 in your calculator and 4 root 2 in your calculator, you would get the same decimal value. Let's do another one. Square root of 60. Okay, as we look at our list of perfect squares, which is what is the largest number that goes into it? Well, if I start with, say, 64, no. 49, no. 36, no. 25, no. 16, no. 9, no. 4 goes into it. The largest perfect square that goes into it is 4. So the square root of 4 times, what times 4 gives me 60? 15. So what's the square root of 4? 2 root 15. Okay. Do a couple more examples. Alright, next one, let's try square root of 45. Okay, so we have the square root of 45. What is the largest perfect square that goes into 45? If I look, 49, no. 36, no. 25, no. 16, no. Does 9? Yes. So, we break this up into the square root of 9 times the square root of 5, and the square root of 9 gives you 3 root 5. So again, it's key to find that largest perfect square that goes into the radicand. Alright. Now what happens if we have, a number on the outside? Well, if we have a square root b times, c square root d, what you need to know is outside numbers multiply together and the inside radicands multiply together. And then you would go ahead and simplify it from here. So when we look at an example such as, 3 root 8. Okay. Looking at this, we would do 3 times. How would this simplify? Well, the largest perfect square that goes into 8 is 4. So it would be the square root of 4 times the square root of 2. Well, if you look right here, this is the same as doing 3 times 2, alright, which simplifies to 6, but then you have to bring this radical 2 down. Alright, and if you plug 3 root 8 in your calculator and 6 root 2 in your calculator, you would get the same decimal value. Okay, let's look at a different example. How about if we did it 2 root 3 times 4 root 5. Okay, again, outside numbers multiply together. 2 times 4 is 8. Inside numbers multiply together, root 15. Now, am I done yet? Well, I have to see if this radical can be simplified. Is there a perfect square that goes into 15? No. Therefore, it cannot be simplified any further, and that's your final answer. Okay, let's do maybe one more example here. Let's do negative 3 root 10 times 2 root 25. So we multiply these outside numbers. Negative 6 square root inside numbers. 10 times 25 is 250. Okay. Well, when I multiply these together, I have to determine, can this be simplified? Well, negative 6 times root 250 will simplify to root 25 times root 10. Yes, you could have seen that right from here. But a lot of times we'll end up multiplying first and then simplifying. Now, what does root 25 translate to right away? Root 25 is equivalent to just 5. So, negative 6 times 5 gives us negative 30 root 10. And this is how we simplify radicals. Go ahead and try the homework sheet on your own. Thank you.